Hello everyone. Welcome to the solution of LeetCode problem 1968 named array with elements not equal to the average of neighbors. Here in this problem, we are given an integer array nums of distinct integers and we have to rearrange the element in the array such that every element in the rearranged array is not equal to the average of its neighbor. More formally, the rearranged array should have the properties such that for each I, where I is the 1 to the array length, where nums of I minus 1 plus nums of I plus 1 divided by 2 is not equal to the nums of I. That means we have to rearrange the element in the array such that every element in the rearranged array is not equal to the average of neighbors. And we can return any rearrangement of the input array that meets the requirement. Here, in the first example, the array contains 5 elements, which is 1, 2, 3, and 4, 5. And if we rearrange the array such that 1, 2, 4, 5, and 3, here we can see that none of the element is equal to its neighbor's average. Here, for this element 2, the neighbor's average is 4 plus 1, 5 divided by 2, which is 2.5. So 2 is not equal to 2.5. Similarly, for this element 4, the neighbor's average is 2 plus 5 divided by 2. That means 3.5. So 4 is not equal to 3.5. And for this element 5, the neighbor's average is 4 plus 3 divided by 2, which is 3.5. So 5 is not equal to 3.5. So it is a valid rearrangement. So here I hope you understood the problem statement. Now the constraint are the array length can be in between 3 to 10 to the power 5 and each of the array element can be in between 0 to 10 to the power 5. I hope you understood the constraint as well as the problem statement. Now let's move on to the algorithm. Now we have taken the first example. The array contains 5 elements, which is 1, 2, 3, 4, and 5. Now here we have to ensure that in the rearranged array, this element cannot be equal to its average of the neighbors. So here we have to deal with the neighbors, and each of the element can have 2 neighbors, either in the right and in the left. So here, as we have to deal with 2 elements, which is neighbor, and this kind of problem can be solved using the 2 pointers algorithm. So here, at first, we will mark 2 pointers. First pointer is marking here, and second pointer is marking here. One is marking to the first position, and another is marking to the last position. Now, we are taking another vector. Each vector contains the pointer value. Suppose we have taken the first pointer value here and the second pointer value here, which is 1 and 5. Now we have to upgrade our pointer. So our first pointer is pointing to this element and our last pointer is pointing to this element. So here again, we have to add the pointer value to the rearranged array. So we have to add 2 here and 4 here. Now we have to again upgrade the pointer. So if we upgrade the pointer, our both of the pointer will point to this element 3. So here we have to add 3 here finally. Now this is the original array and this is the rearranged array by using the 2 pointers mechanism. So let's see how can we satisfy the condition such that each array element cannot be equal to the average of its neighbor. Suppose here we can see that this element 5, both of its neighbor 1 and 2 is less than 5. So here we can see that as both of the neighbors is less than to the current element 5, then the average of the neighbors cannot be equal to the current element 5, because as both of them are less than 5, so average will be also less than 5. So the average will not be equal to the current element 5. Now similarly, for this element 2, the neighbors are 4 and 5. So here, both of the neighbors, 4 and 5, are greater than 2. So here, obviously, their average will be also greater than 2. So that means both of the neighbors' average cannot be equal to the current element 2. So again, for this element 4, the left element is 2 and the right element is 3. And their average will be 2 plus 3, which is 5 by 2. That means 2.5. So 2.5 cannot equal to the element 4. So here we can see that if we rearrange the array into the 2 pointers mechanism and append the value of the first pointer and the second pointer subsequently, the rearranged array in each of the array element cannot be equal to the average of the neighbors. So I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named rearrange array and input vector. After that, we have to sort the input vector. This is the algorithm, because if we do not perform the sorting algorithm, then the 2 pointers approach may not work properly. So here we have to perform the sorting function into each of the input vector. After that, we will take 2 pointers I and j, and in each iterations, if I equal to j, we have to insert the a of I 1 times. Otherwise, we have to insert both of the I and j into the corresponding rearranged vector and increase the I pointer value and decrease the j pointer value. After that, we have to return the rearranged vector. So this is the code. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n log n, because we are using the sorting function on the input array, and the size of the input array is n, where n is the number of elements presented in the array. So here the time complexity is big O of n log n, and the space complexity is big O of 1, because we are using constant extra memory to solve this problem. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.